So this is a tale of two plugins safely extending the Kubernetes Scheduler with WebAssembly. So we have a QR code here to the slide. So my presentation tends to have like many pages and proceed very quickly. So I recommend you get the slide in your laptop or phone, whatever, so that you can be back to other pages anytime. So I'm Kensei, a young boy from Japan in a TikTok generation. So you'll find me with the ID Samposhiho everywhere, like GitHub or Twitter. So yeah, I know no one cares about my icon, so let me just replace it with the QR code. So I'm a platform engineer at Mercari, which is the largest marketplace app in Japan. So I'm also open source lover. So apart from work, I'm contributing to Kubernetes as a single scheduling approver in my free time. Yeah, that's about me. So here's the agenda for today. We don't have much time, so I'm gonna go straight into the topic today. After introducing about the scheduler a bit, I'll show you about like how it provides the extendability to users and some use cases around it. And also, I'll show you the advantage and disadvantage of each way to extend the scheduler and explain why we are attracted by WASM. Then we'll get in the WASM extension topic. We'll see the overview, how it looks like, and technical details about it. And yeah, at final, we will see some like project status or what's next. So let's start. Starting from the very basic knowledge, so the pod is a group of containers. It's the smallest execution unit in Kubernetes. And node is the virtual or physical machine where those pods run. So Kubernetes Scheduler is one of the core components in Kubernetes, which literally schedule each pod to some nodes. So it checks many factors like resource requirement, scheduling constraints like pod affinity, etc., and decides the best node for each pod. So let's see how the scheduler currently provides the extendability. So generally speaking, you have several ways to control your scheduling. So they are classified into two categories. Basically, like you can start from the first group, using built-in scheduling feature. So the first one, there are many scheduling constraints available on the pod spec, like this node affinity, pod affinity, pod topology spread. Yeah, we have more actually. And most of general such use cases should be covered by those built-in scheduling constraints. And we have scheduler configuration to change the behavior of the cluster, scheduler. But in the built-in scheduling features, constraints, we only support like very general features for everyone. And if your use case is like a bit unique and isn't covered by them, then you start to consider extending the scheduler. So currently, we have two ways to extend the scheduler. So extenders, plugins, and we are starting the WebAssembly here. So if you have unique use cases, then you might need to extend the scheduler. So the batch job requirement is one of the hot topics around the scheduling area these days, or maybe Kubernetes world in general. And you can find many other unique use cases in this repository. And so let's see how each extension looks like and the advantage or disadvantage there. So the first one is the extender, which is the just webhook. So it's the scheduler calls webhooks at those 4 points, and each point has different role as you see. And so here's the advantage and disadvantage of the extender. So the advantage is that it doesn't require rebuilding the scheduler. So just put your URL into scheduler configuration, and also it's just the HTTP server, so you can implement it via any language you want. But there are some disadvantages as well. The biggest one is the performance. Let's see how bad it is. So it's a benchmark result on my laptop. So it shows how long it takes to schedule one pod in a particular scenario. So this is a result from the default scheduler without any extenders. And this is when I add one extender. So it takes 10 times bigger time to schedule one pod. So of course, it depends which scenario you run or on which laptop you run though. We can see it surely affects the latency very badly. So based on the disadvantages of the extender and many other reasons, the scheduling framework was established. So it's the pluggable architecture inside of the scheduler, and it's so we basically wanted to decouple all scheduling logic from the scheduler's core code and implement all of them as a plugin. For example, we've got the node affinity plugin for implementing the node affinity. And yes, so you can create your own plugins to satisfy your own use cases. And this is the second way to extend your scheduler. And also, scheduling framework has the concept of extension points. So each extension point has a different role, filters out some nodes which can't run pods, or scores nodes to calculate the best node among them. So each plugin works on one or more extension points to achieve what they want to do. And so let's see how to implement our own plugins briefly. So it's each extension point has the interface to be satisfied, and here is the interface for score extension point. You see the score function. And if this plugin implements the score extension, score interface, this plugin can work at score extension points. And we are going to integrate this plugin into the scheduler because it's our custom plugin. So by changing the scheduler's implementation directory, and of course need to rebuild this scheduler. Oops. And then you gotta enable the plugin in the configuration, and then finally, there we go, we can run our plugins in the scheduler. So this design works well, and this is actually a current recommended way to extend the scheduler. The advantage of this is that as we see, there are many extension points available, and plugins can operate the scheduling very finely. Also, it's just a Golang function code, so there's no overhead. So technically, it works really well. But let's see. So one disadvantage here is that it can't be used casually because it requires rebuilding or something. So first, there's maintenance cost, of course. You got to fork the scheduler to integrate your plugins and need to keep up to date along with the Kubernetes versions. And so the scheduler also should be only one in the cluster, basically. So you may need to convince other people, may need to manage many plugins from different teams in one scheduler. So such obstacles from it, can we really call it pluggable? So yeah, it's pluggable internally for sure, but it's not like push one button to enable plugins, right? You need to rebuild the scheduler. You need to go through all of them. So for example, my company has the huge one cluster to run all microservices, and there are many ideas in the platform team to improve our scheduling in our cluster for our specific use cases, but they're just nice to have, and we can still schedule our pods via default scheduler because we don't run such bad job or stuff. So actually, extending the scheduler doesn't get on our table, isn't in our options because of those hurdles. So our nice to have scheduling like such enhancement ideas do not overcome them. So as a scheduler maintainer, so in the scheduler maintainer team, we really want to make the scheduler like truly pluggable, so make it easier to extend. Then there we go. We are attracted by the possibility of WASM to provide new extension experience. So WASM is quite new stuff. So it's a way to run your code compiled from other languages like Golang, Rust, etc. And WASM runtime execute WASM guest. It's meaning like .wasm file binary, and WASM guest usually imports functions from host, and so to perform some tasks. So it means that guest can't do things that host doesn't allow to do. So you may have heard of WASM on the web browser, but so actually it started to be used not only in the browser, but also in the backend side to provide such extendability. So some of you may have already known about this WASM extension in Envoy and Istio. So it's just one example. So nowadays there are some other projects that provide such extendability via WASM. So we also started it as an official sub-project of Silk scheduling. In the future, we may or may not integrate it in the Kubernetes, upstream Kubernetes, so that it should be available for everyone. But yeah, I hope we will, but let's see. So from here, we will see how it looks like, and we'll go down, go to a technically deeper place after that. So actually, WASM extension is implemented as a Golang plugin in the scheduling framework. So it's just like a wrapper to enable your WASM guest to run existing Golang plugins. So it hosts the WASM runtime in it, powered by WAS0, which is the zero dependency WASM runtime for Golang. It doesn't also require Seagull, so it's cool. It loads the WASM binary passed by the configuration and run up the WASM guest from it. And we know it's tough to, for non-WASM people to write on WASM binary, so we provide SDK. It plays a crucial role for such non-WASM people, and to provide better developer experience. So we provide it so that people can develop it via very similar experience like Golang plugins. So let's see. As we saw, it has also another interface for Squad plugin, and people only need to implement that interface, and they can just compile it to WASM binary. And like the existing Golang plugins, we gotta enable WASM plugin in the scheduling configuration, and it enables in the configuration like this. So here you pass the WASM binary. So note that the WASM binary can be passed not only via file system, but also via network. So maybe in the future you'll be able to go and see community managed WASM plugins and just apply good ones to your scheduler without much effort. That's cool. So then will WASM extension replace all Golang existing plugins? The short answer is no. So it's just a balanced solution between extender and Golang plugin. So like Golang plugin, you can utilize all extension points, and like the extender, you don't need to change the scheduler's code. So you don't need to rebuild. You don't need to overcome such hurdles. But there's still a disadvantage of latency again. So it's the same one, so the latency of the default scheduler. And so it's the result of the WASM plugin. So I just twice through with WASM extension. It means remember that as we saw, here is the result of extender. So yeah, much all right, right? So the latency impact from WASM is very okay compared to the extender. So the conclusion is like, even after the WASM extension matures, the Golang plugin still can be the best option for someone because of such latency impact. For example, if you need to be very careful about the latency, or like you need to do heavy calculation, then you may need to choose Golang plugins instead of WASM ones. All right, so far we are talking about the surface level of WASM extension. So I'll take you a more deeper price from now. So again, this slide. So the WASM plugin is implemented as a Golang plugin in January, and it has the WASM runtime in it. It loads the WASM binary and run up the guest from it. So this is what I said, and let's see more deeply about how they communicate. So here we go. So when the scheduler calls future function in a future extension point, the WASM plugin calls future function defined in the WASM guest. So the guest may need to fetch some resources like port, node, etc. to make a decision, and eventually returns the result to host. And then WASM plugin returns the result to the scheduler on behalf of WASM guest. So we are using ABI to define how they communicate in each function call, like this. So there is a concept called ABI, which stands for Application Binary Interface. It's like, API, contract of how the host and the WASM guest communicates. So to define the ABI, you have to understand how the objects are handled between host and guest. So there is a unique WASM implementation from its sandbox model. So the guest can only operate their memory. So they can't directly access things in host's memory. So it means that we can't pass object from host via pointers or something. And also, even as values, we can't, because as written at the bottom, so we can only pass numeric types through WASM functions. But on the other hand, the guest memory is exported to host. So host can read or write anything in their memory. So we can utilize this to pass object from host. Let's see this again. So here is the common way how the host passes object to guest. So the guest passes the linear memory offset and address and maximum length in bytes, so that the host can write URI data in designated place in their memory, guest memory. And when this function is called from the guest, it's host puts the URI there and tells guest about the length of data, and the guest can read the data from their memory accordingly after that. More understandable diagram here. So the guest, in this case, calls the function with the address 16 with some maximum limit. And the host puts the URI full bar to the memory from 16 and returns the length of it, in this case 8. And then after that, the guest can read the URI from 16 to 23. So in this case of us, Kubernetes object has thousands of fields, and it's unrealistic to define function to fetch each field. So we decided to define one function to fetch each object, like getPort, getNode. And each function passes protobuf encoded object to the host. So yeah, it has a disadvantage of the performance again. And it means that the host and the guest need to encode and decode the object every time. So yeah, so there are overhead there. So I'll show you some things we've already done around the performance enhancement there. So the first one is lazy loading. So all WASM function don't need to access all objects or all parameters passed from the functions. So we implement the lazy loading. So in this case, pre-score interface has the parameters of port and node list, and port is used in this function, but node list isn't. So the port is fetched from the host when port spec is called, but node list isn't used, so we don't fetch it from the host. So moreover, we have cache in the WASM guest side. So the scheduler takes snapshot of ports and nodes before starting each scheduling. So it's because each plugin can need to decide the scheduling result based on a consistent condition of a cluster. So we have a cache for it, and by lazy loading and cache system, we reduce the number of communications between host and guest as much as possible. So there's another unique thing that affects the performance here. That's garbage collection. Since we are using the huge object and doing marshal and marshal stuff, it makes huge garbage in memory. So WASM can only have one thread, so Goruchin doesn't work. And so garbage collection is inline, it directly affects the performance. So especially talking about the garbage collection in TinyGo, it's optimized for code size, not the speed. So it's not as performant as we want. So we explored some alternative here and currently recommending users use not TinyGo. Yeah, I like this name. So we saw a half latency reduction in some scenarios by switching to it. So not TinyGo is optimized for speed, not code size. So that's why it's not TinyGo and not TinyZC. Yeah, sorry. And for now, we don't use it by default in SDK because this not TinyZC is very new and currently only has one contributor. So yeah, but it's very great, and we recommend it to use it in the documentation and stuff. And also, we implement the benchmark test and keep checking it when we have some changes that may affect the performance. It's very great to see how actually reduce the latency in each pull request and stuff. All right, so that's almost all about my WASM talk. So let's see the project status and what's next. It's very early stage, but it has enough functionality to write very simple WASM plugins. So yeah, you can go and see some examples here. Yeah, I'm not sure you can click it or not. So. And what's left to do? So currently, not all extension points are supported yet. We definitely should put more effort to support all of them. And also, we provide only ports and nodes to the guest. So we need to provide some general way to pass any Kubernetes object to the guest, because some scheduling plugin even requires CLD or something. So some flexible way should be implemented. Also, the performance enhancement should be done. And yeah, we only have TinyGo SDK currently, so we should at least have some examples to how to implement the WASM guest in other languages, or yeah, if we could some SDK as well, then it'd be the best. Yep, so that's all of my presentation. So thank you very much.